back a little bit from last day. So, okay, so can the, let me just hit it again, just make sure. So I'm on the viewer, so hopefully both sides can see the viewer. Okay, so you can see image on the screen. Okay, we are, I want to go back slightly from last day, and then we'll continue from there. So we were talking about last day about some properties of this, some properties of the surface, and we talk about things like, you know, two-dimensionality, heterogeneous of the surface, and the surface are mobile, and we have positive free energy, and usually a dirty surface that we're looking at, this sort of thing. So, and then we talk about how we would study a surface, and we point out that you have to, generally there are, in my opinion, there are four things that you can look at. You can look at physical structure, you can look at the electronic structure, and then you can look at composition. So chemical information, both in spatially two-dimension and also in the depth dimension. So oftentimes this is known as depth profiling. So you profile the either the chemical state or the elemental composition in terms of depth, and then you can also see spatially in XY direction how these compositions change. Of course, what you want to do is to try to correlate this chemical information with the two other information that you have, which is atomic position or physical structure of your surface, and then if you could try to correlate with this electronic structure. So in terms of small object, like nano object, that become a rather challenging task because simply because of the dimension of the object that you're looking at, and in terms of composition, as we'll see, a lot of the composition analysis technique involve destruction way. Basically, you involve sputtering, which means that removing layer of material. And if you are talking about nano object, you don't have a lot of material to begin with. So the technique has to be very quick, otherwise everything is gone, and then you don't have a second chance to see what you've got. Okay, and finally, the fourth thing that we are interested in, usually in this material as chemists, is what you can do with it chemically, reaction-wise. You know? So you can, is there any unique reaction that you can have in this case? So a good example, a very good example is gold. Everybody knows gold is a very inert material in the powder form. That's why people have gold ring. And gold, of course, one special feature of gold is that gold doesn't form oxide. Okay, so you know that you have a good metal on the gold. But if you reduce the gold to small size, maybe 55, below 50 atoms, to create a cluster, sort of a nano cluster of this gold, gold become extremely reactive. Okay, so you can see that once you change the dimension, the chemistry, and in this case I would say the surface chemistry that's occurring on the cluster will change dramatically in this particular case. Okay, so these are all the sort of item, the topic of interest, the feature of interest that you would have in terms of studying these nano objects. Most of it are services related. Okay, so we were looking at last day as well how to do this, and most of the time involve some sort of vacuum chamber, and people are moving away from vacuum chamber sometime because the challenge has always been try to measure your nano object in its natural state. This becomes extremely relevant if we are looking at biological material. So vacuum is inherently hostile to biological material, and people are trying very hard to come up with new technique to get around this vacuum problem. And the vacuum you need simply because of the pro particle that you need. So a lot of the time, in most of the technique that we will talk about, involve electrons and ions. So these charged particles would not survive very long in air because it got absorbed by air, or its trajectory got changed by air. So you would not be able to see, you will not be able to obtain the information you get if you are looking at scattering emission of these charged particles. So that's the primary reason why you need vacuum to to preserve, if you like, to preserve the trajectory of your probe particle, which are mostly charged particles that's being used to probe the surface of your nano object. And we talked about last day how you clean. So I would skip this, and because we looked at this last day already, and we will today we will hopefully we could give you a tour of some of these this technique. I have listed a few of these characterization. This feature involving physical structure that we talk about. There are quite a number of them, both microscopy technique as well as diffraction technique. We'll look at them a little bit more detailed, perhaps later on. And then there's the electronic structure. You remember we talked about physical structure, the electronic structure, and then composition and chemistry, and there are different techniques involved in this. Mostly involve some sort of sputtering technique or desorption, either using temperature to dissolve as in thermal desorption, or electron to dissolve as in electron simulated desorption, or photon to simulate the desorption, photon simulated desorption. And we'll look a little bit closely at that as we go through the material. And then two things that I haven't talked about that often is used as well, which is you have this four type of information, if you like. You have physical structure, electronic structure, composition, and chemistry, right, which is reaction. From these, you can do something really useful because you can make practical application by making devices. And so those are, I list also two classes of technique that you use to make a device. Not just, as chemists, we know how to build material because we know how to synthesize things and put them together. But for the engineers, and if you want to sell something, you want to make where you added material, so you want to put these material together, put this substance together to make a device so that you can actually make up different components and then get signal out and then tell the user, consumer, what you want to do with this device. So if you all do that, and the engineer will particularly be interested in this. There are different techniques, both in terms of fabrication, and fabrication usually means thin film fabrications, but as time evolves, it doesn't need to mean like that anymore. But most of the time it's coating and thin film. So a lot of these are film-based technique, and people, a film is not very useful, not very interesting, because it's just a layer of material in the Z direction. More interesting is to make some pattern or circuit, if you like. And so you need to have some sort of pattern tools. So you have fabrication tool, which is really depositing, and then fabrication tool, you would have lithography, both optical, electron lithography, and maybe nanolithography, which you use single atom. And recently, of course, there's a lot of stenciling technique. Basically, you're stamping. You create a nano stamp, and then you stamp very much like postal stamp. You stamp your material and to create a pattern you want. And that emerged in the last 10 years. This sort of nano stamping techniques that come around. Okay, so these are useful after we gain information on the material, which is our component. Now you use these two